What is a confusion matrix in machine learning? In this video, we will try to understand that. Let's say we have created a model for logistic regression. The model does classification based on the predicted variables or the features. For example, let's say we have details about the sepal length, sepal width and petal width of a flower, and based on these features, the flowers are classified as type 1 or type 2. Let's also assume that when the target variable is true, it means type 1, and when the target variable is false, it means type 2. Now, some inputs are given to the model and the model outputs like the following. Let's say, as per the actual classification, the output should be like the following. So, how well did the model perform? To know that, we need to measure the performance of the model. Using a confusion matrix, we can measure the performance of a machine learning model that solves a classification problem. Before we understand the confusion matrix, we need to understand a couple of terms. They are true positive, true negative, false positive, and false negative. What are they? Let's try to understand that first. True positives are those output labels that are predicted to be true and they are actually true. True negatives are the output labels that are predicted to be false and they are actually false also. False positives are the output labels that are predicted to be true but they are actually false. And false negatives are those output labels that are predicted to be false but they are actually true. Now, let's try to understand what the confusion matrix is. In machine learning, the confusion matrix can be represented like the following. So, in our example, the actual output is like the following and the predicted output is like the following. So, the total number of true negative is equal to the output labels that are predicted to be false and they are actually false also, and that is equal to 3. False positive is the output labels that are predicted to be true but they are actually false, and that is 1 in our case. False negative is the output labels that are predicted to be false but they are actually true, and that is 1 in our case. And true positive is the output labels that are predicted to be true and they are actually true, that is 5 in our case. So, the confusion matrix will be like the following. I hope this helps. Interested viewers who want to know more, please visit the website of the Security Buddy or refer to the playlist Statistics for Machine Learning. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.